Hi everyone, I'm Chris Saxon. I'm part of Stephen Feuerstein's Oracle Developer Advocate team. It's my job to help you get the best out of Oracle Database and hopefully have some fun whilst doing so. So that's great to be here on these office hour sessions so we can have your questions, look into topics that you find interesting. We did have a question come in advance. Someone had a query that they wanted help tuning with. So we're going to break it down a bit, look at some things they could have done, and see if we got any ideas about how we might have tuned that. Alrighty then, so let's bring the slides back up. So let me just go back over there, and hopefully you can see my screen now. Is that got that screen up? I did share that, didn't I? Yes, we're sharing. Okay then, so hi everyone, and as I said, the person had a query come in, and it was quite complicated. So I've just extracted an interesting part out of it, and we'll kind of walk through what some of these things actually mean, and then we'll build it up slowly as we go along. So basically, they had a query, and there was various criteria they were doing, and they were searching a column for a particular value, but also, quite importantly, they had a date, and they were searching that for a range of values, and they had a problem. When the date range was small, they were kind of getting what they were looking for, but when they increased it to a large value, then the query slowed down a lot. Now, the obvious answer here is, why does it do that? Well, processing more data, but there's a little bit more to it than that, as we'll see as we go through this session. Excuse me. Alrighty then, so before we jump into what's going on, let's just ask some high-level questions about how the optimizer breaks this down. So when you send a query to the database, it's the optimizer's job to kind of go, well, how many rows do I think I'm going to get from the table? And therefore, how should I access it? Should I use an index? Which index should I use? Should I go with full table scan? That kind of thing. So it's got to make these decisions based on the stats about the table. So let's split this query into two. We've got two things here. One where we're just looking for a column equals a particular value. So nice and simple, about the most straightforward thing you can get. So this is my question to you, a little test to start with. If we send this query to the database, how many rows is it going to return? Now, obviously, I'm not looking for a number of exactly how many rows. What I'm really looking for is a general strategy. How can we estimate how many rows? Is there a formula we could use to figure out how many rows we're going to get back from the table? So comments in chat, let me know what you think, any ideas. I'll cover off the easy one. Obviously, we might search for a value which doesn't exist in the table, in which case we'll get 0 rows back. Let's ignore that. Let's assume we're searching for this buying variable equals a value that really is in the table. So what high-level strategies could we use, or formulas could we use to kind of estimate how many rows we're going to get? Anyone going to be brave in chat and put something down, or go on, open their mic up and suggest something? Without bind peaking, we cannot know. It depends, 5%. Well, obviously, it always does depend on exactly what's going on. But there are a couple of high-level strategies we could take, some basic principles about how to, stop sitting on the fence, everyone. Stop saying it depends. Come up with, it doesn't have to be an exact number of rows, a formula or a strategy you could use. So Rafu's suggested 5%. Anyone? Distinct rows divided by number of rows. Okay. Steve saying index. So we've got Sven going distinct divided by number of rows. Well, I would, depends on what exactly you're looking for, but Sven's kind of hit the thing that I was looking for there. We can know how many different values there are in this column, and we can know how many rows there are in the table. So as a very basic guess, we can just divide one by the other. Say, take the total number of rows. Let's say we've got 1,000 rows, 10 different values, 1,000 divided by 10. We can expect roughly 100 rows for this query to return, assuming there's an even distribution of values, or roughly even distribution values. Obviously, the data in real world is much more messy than that. It's pretty unlikely you'll have an even distribution values. So in those scenarios, what we can do is use a histogram. So there's a couple of high-level level strategies, number of rows divided by the number of distinct values in this column to give a guess. Or if we've got a histogram, there's an uneven spread, the skew in that data, we can use that to estimate. Now, I'm not going to get into the details of how histograms work. That's kind of a session in its own right. But basically we can see 4 particular values, some are more popular than others, and kind of estimate that way. So those are 2 high-level strategies, and either of them, as you know, if we've got an even spread, the first approach works pretty well. And if we've got a histogram, again, as long as the histogram's roughly broadly up to date, that tends to work reasonably well. So we've got a couple of high-level strategies to estimate this, and we can do okay most of the time. What happens if we've got a query like this? Right? We're looking for how many values, we've got a date value, and we want to find how many rows fall in a particular range for a start date and an end date, and how many rows have that value. How can we estimate how many rows this query will return? So again, any ideas, any thoughts on how we might try and approach this and figure out, you know, some estimate of how many values we're going to get back from the table? Anyone, any takers? Anyone going to suggest something to me? It's a bit trickier, this one, isn't it? It's a bit trickier to figure out what might actually come back, how many rows are going to come back. Supposing uniform distribution, then n minus start minus over max minus min. That's a good way to approach it. Judith, yes, we could do that. But the problem is we don't know what the start and the end are at this point, do we? Or, you know, just a general, what are those start and end values? If we're checking a value column equals a particular value, we can make an informed guess without even having to know what that is. But to make any kind of informed guess, we have to know what those start and end values actually are. Without it, it's just like, well, I don't know, could be anything, right? It could be that actually we messed up our query and put a start date that is after our end date, so the query will never return anything. We could pick start and end dates, start which is lower than the smallest value in the table, and an end which is higher than the biggest value in the table. So we're going to return everything. And there's all sorts of mixes in between. Short answer is, without some idea of what these values are, we literally cannot figure out a reasonable estimate for how many query rows it's going to get back. There is just no way to do that. It entirely depends on the relationship between those values. So how do we do that? Well, we need to look, or peek, as we say, at what these buying variables actually are. So this is a technique which has been around in Oracle database basically forever. You submit a query to the database. First time we run it, the optimizer asks, well, what values have you passed for those buying variables? And therefore, how many rows do I expect this query to actually return? Produce a plan based on those buying variables. So that's kind of like the high level thing here. I'm going to jump into demo now, and we're going to spend pretty much all of this session talking about demos, or showing demos, showing how this all works. Let me just build that. So what comments, questions do people have at this point? Does this seem fairly straightforward so far, hopefully? Okay, so we'll hope, there we go. Build table. Okay, so I've got a table of appointments here. Let's say they're hospital appointments or doctor's appointments, something like that. And we've got a range of dates in here. So I've grouped it up by month, and you can see we've got about 10 rows per day in the table. So each day has about 10 appointments for it. So we've got around 300 rows each month. So, and if we just info the table, so that's the new version of describe on steroids, which gives a lot more detail about the table. We'll see, we've actually got some indexes on this. There we go. We've got like start and end date, consultant location, the appointment, and we've got a couple of indexes on here. So thinking, come on. And I'm going to run some queries against this table, and we'll see what happens. Okay, come on. All right, then, there we go. We got the indexes at last. So we've got an index on the consultant and an index on the start date, and we just got 4 other columns in the table. So the first thing I'm going to do is run a date range query like this. So I'm going to pick a small date range to begin with and look at what execution plan we've got. So we've got an index on this column. We'll look at it for just 2 days, the 1st of January to the 2nd of January. Before I run this, let's have a little guess. Who thinks this is going to use an index? So you can just tick the yes or no buttons on the little chat window, on the participant window, or say in the chat what you think. So is this going to use an index, yes or no, when we're just looking at a couple of days worth of data? So we've got 1 yes. Sven's going yes. Any other takers? 2, yeah, a couple of yeses, 1 no, okay. Anyone else? Oh, a few no's, okay. Any other takers? Well, let me bring this up. So what I'm going to do is run what we call auto trace in SQL Developer. So if you're not familiar with this, it's this little button up. Come on, pretty sure it's this one. No, that's the explain button, auto trace button. So I'm hitting the F6. This runs the queries, captures execution stats about it, so we can review, see what the query actually did. So let's run this, put the value in. Oh, we've got another person going for yes, and we're going to put in, let's put that to the 2nd. Okay, so 1st and 2nd of January this year. So any other last takers before we run this query? All right. No. Okay, let's run it and see what we get. So we get our auto trace, and this will tell us, and it uses the index. So we can see we've got the index in the table there. And we're returning few rows from the table, just 10. So this is kind of what we'd expect. There was, if we look back, there's getting on for 3 years worth of data, about 300 rows for each month. We've got quite a lot of rows in this table, and we're returning just 10 of them. Very small fraction. We would at least hope that this would use an index. We would, you'd seriously hope that we'd get an index for this thing. But of course, as I said, it entirely depends what values we pass in for the start and end date. So when you have range-based queries like this, using bind variables, the database marks it as bind sensitive. This means that the plan we use might change depending on what these values actually are. So we've got bind sensitive, yes. So if we run the query again with different values, we might get a different plan. Okay, so that's what we're going to do. So 2 days, we got used an index. Now I'm going to get a full year's worth of data. So first of all of 2019's data, basically. Run this query again, and which plan are we going to get this time, index or full table scan? So to run this query again, who's going to vote index this time? Oh, we've got some yeses, no's. Well, more no's, or quite a few no's. Okay, so let's run this, put this in. Let's actually bring it up. And 2020, 01, 01. We have quite a lot of no's this time. So let's run and see what happens. So we've got the query. We are still using an index. Oh dear. We are returning a large fraction of the rows in the table. So about a third. So 3,500 rows. The database has still decided to use the index. That doesn't feel right, right? We're getting, there's 10,000 rows in the table. We're getting over a third. Probably we want to use a full table scan. If you're fetching a large fraction of the rows from a table, you probably want a full table scan. But we still got an index. So why is this? If we look at what's going on for our database, we can see the database has said it's bind sensitive. We might change the plan based on what these values are, but it hasn't actually done that. Is someone beeping in? Someone want to make a comment at this point? Yeah, okay. So a few people saying full table, bind sensitive, bind aware, and so on. So that's a great point. Sven, we've said it's bind sensitive, and you see there's got another column here, bind aware. We're saying it might change based on the values we pass, but it needs to be aware that that actually is a necessity. You know, it's possible we could pass different values and end up with exactly the same plan. We'll see an example of that in a minute. So what we do, the first time we run the query, we peek up what the values we passed are and say, which plan should we use based on those variables? Okay. Okay. So Judith, after the second run, wasn't it supposed to mark it as bind aware? So not after the second run. We have to run it a third time. Okay. So we've run it once with our initial values, and we're going to run it again for all of 2019. And now we switch to a full table scan. Now it is realized that for that second date range, the whole year, the index was the wrong choice. It should, in fact, have used a full table scan. And if we look at the cardinality, the estimate of how many rows we're going to get, it now matches exactly the number of rows. I don't need to worry about that. So if we query what's actually going on now, we'll see there are actually two cursors for this query. The original one we passed, where we said the plan might depend on the values, and the second one we actually got, where it switched from the index to the full table scan. And you just behave dirtily and use the bind aware hint. We know we shouldn't really be using hints there, Judith, so let's just work with what we've got for now, or, you know, plain SQL. So the thing to note here is the database had to get it wrong once, or at least once, before it picked the right plan. So we peeked, chose an index, that was right for our first query, but our second query, it was the wrong plan. And we already had a plan available. So we thought, well, let's just use that. Let's use that existing plan we've got available rather than go to all the effort of trying to produce a new plan. And then once we've done it, then ask ourselves, was that the right plan? Could we have done any better here? And, you know, it's looking at things like kind of going, well, how many rows did we predict versus how many rows we actually got? Are those roughly in the same ballpark? You know, how long did it take to run the query? If it's finding a big mismatch, so it's going, yeah, we probably got this wrong. We want to try again next time we run the query. So this is the basis of something called adaptive cursor sharing. It can spot that based on the bind variable values we passed, there could be a different plan available, or there might be more than one plan for a SQL query. But the key thing is the first time we run the query, it picks a plan. If another set of values need a different plan, it will still use that first plan at least once before it picks up that we need to change plan. Okay, so Judith, once Oracle knows that the plan does depend on the bind variable values, why doesn't it mark bind aware from the first run? Yes, Sven, I don't think bind aware is in the same league as other hints like a use index. Yeah, that's a fair point, Sven. But coming back to your point, Judith, well, the thing is, we don't actually know. I mean, we know running this query roughly what it's going to return because I've looked at the table and I've kind of talked you through it. But in the general case, we don't actually know how many rows a query is going to return until we run it, right? So that second time we run the query with that year-long date range, we don't know for sure that it's going to return significantly more rows. It might do. I mean, I've told you it will. So you go, oh, yes, it will. But imagine I told you nothing about that table. You know, we might have had just 2 rows for the 1st and 2nd of January this year, and all the others might have been previous ones for prior years, or maybe there's no other rows in the table. Who knows? Point is, we have no idea how many rows there are until we run it. So rather than go to all the effort of, you know, trying to produce a new plan, we stick with the plan we've got, and then after the fact say, was that the right plan? And these bind sensitive, bind aware settings are specific to that plan it generated. So we used the plan, figured out it was the wrong one, and then had to create a new one, which is bind aware. Okay, so does that help answer the question, Judith? All right, so Sven, bind aware hint. So it is not one of those hints we should avoid. Well, you know, it's, yeah. It's perhaps more arguable than things like using an index. I think it's better to try and avoid hints as much as possible, because otherwise it becomes a difficult, harder message to tell newcomers. Never use hints except these ones. And if you just say avoid hints, it's an easier message and people are easy to follow. Certainly when people are getting started. Obviously, as we progress and learn, well, actually, yes, there's circumstances where this might change. It's important to be aware of that. Okay, so more comments. So Judith, we do know that the plan does depend on bivariables, except for the case when the clustering factor is so bad that it will never go for the index scan. Sven, this hint will not seize the execution plan. Oh, you want to use it, Sven, that's fine. Go ahead. Like I say, it is one of the safer ones, but I think it's better to avoid hints generally. So Judith, your point, when the clustering factor as an index is so bad it will never go to the index scan. Well, we can never be sure of that. If your query is only going to return one row from a table, it is almost always right to use an index to fetch one row from a table. There's almost never a case where it's better to full table scan, even for really tiny tables which only have a few rows. So you can't say it is very unlikely. We can say it's very unlikely we shouldn't use this index, but it's almost impossible to say we should never use this index. And of course, actually, if an index is so bad that we almost basically never use it, why do you have that index? You should probably drop it anyway, right? Okay. The hint, okay, so another comment. The hint will just spare the required single bad plan, but why does Oracle need that bad plan at all? Well, it's the right plan. Remember, it was good. It was good for the first query we ran, okay? It might not be good for the second query we ran, second set bind variables, but it was perfect. It was exactly the right plan for that first query we ran. So, the concept of good or bad is all relative. One query can have two good plans, or equally, depending on which way you look at it, two bad plans, depending on which one we choose. So we can't just kind of say, well, that's a bad plan, never use it, because the first time we used it, it was the right plan. It was the good plan. So there isn't a way to kind of, in some ways, it's a bit of a chicken and egg situation. You can't just discard it and say, we know it's bad, because you don't know it's bad, until you've run the query and actually found out. What other questions or comments do people have at this point? So good discussion here. Okay. I mean that from the first execution, it should mark the query as bind aware. So that's an interesting point, but actually, remember when we mark it as bind aware, we are adding extra overhead. We're telling the database, each time you run this, well, you've got to do a bit of work to kind of think about whether this is the right way to do it. By default, it's better to be lazy, do less work, and be efficient. And that's the approach we take. And say, do the minimum work we can, and then check later whether that was the right amount of work. So rather than kind of just mark everything bind aware, in which case we're potentially re-optimizing, repassing these queries all the time, it's worth thinking about that. But if you want to add this bind aware hint in, we are doing the database is going to have to do some extra work. And a lot of the time, we don't need that. I mean, a lot of the time, depending on your application, it might be that you restrict people so they can only search for 2 or 3 days worth of data or something like that. Or maybe just the nature of the data that we're working with means that the full table scan will never be the right choice here. I've got this appointments table's only got about 3 years worth of data in. So likely, if this was like a real world hospital system, it could have 50 years worth of data here. In which case, searching for a full years of appointments, the index might still be the right choice. So it entirely depends on your data. Okay, so some more comments. So optimizer, Sven, optimizer simply doesn't know how many values between these two new bounds, so it's okay. It needs at least one bad try. Yeah, I agree, Sven, and hope that's what I was trying to say. So Judith, there are actually 2 possible plans, so after getting those, they can be reused. That's right, Ulyss. So once we got our first good plan, we then used it, found it was kind of bad, and then generated another good plan. So we can now switch between them. And this is a nice simple query. There's only really two options here, but with big complicated queries, there might be 3, 4, 5 possible good plans depending on your values. Okay, question from JP. Chris, when you revert to the first situation, so day 1 interval, which plan will it use? Okay, so let's have another little guess here. What do we think? Who's going to vote? Well, let's search for a different day. Let's do 2020. First and second 2020 of January. What do we think is going to happen here? Are we having any guesses? Index, yes or no? A lot of people not quite sure. More no's going in this time. Nope. Yep. Let's try. Let's see what happens. And it's gone for a full table scan. Interesting. Interesting. So if let's run it again. Now, hopefully this time it will now. Oh, it's still going for a full table scan. I did put those values in. Start and end. Yep, there we go. Oh, it's still picking a full table scan. It's not picking up this change. Let's see, have we still actually got... Yeah, so we still got the 3 plans. I'm not convinced about what that's showing me. Actually, let me try running... Let me just pick these up and see what's actually going on here. Let's get the DBMSX plan on the case. Let's change those to 2020. Because we can see we now actually got those 3. Let's run this. Okay, still going with a full scan. It has still gone with a full table scan in this case. Okay, interesting. Although it has estimated correctly. Notice that it is a slightly different plan, because this one, the one for our other date, had estimated the cardinality in the thousands. So maybe it's just decided in this case the index is not good enough in this situation. So, it depends a lot. It depends on your data. It can switch between them. If we switch back to 2019, 2019, what's going to happen now? We will find that, it goes full table scan, not surprised. Let's try again. Still feels like, okay. Slightly surprised by that, but in general, it can now switch between the plans. And when you've got multiple of these plans available in the cursor cache, the short answer is you don't necessarily know which is going to pick. And particularly if you've got applications where people are putting a lot of different types of values, kind of things you might get if you've got date range searches, for example, it's possible a lot of people might get lucky or unlucky and end up switching between plans. So things can change around a bit. Okay. Wow, that's strange. The old value should result in plan with the index. I would have agreed with you there, Sven. I'd have to dig around a bit more see what's actually happening. One possibility is I've been chatting quite a while here. Eventually plans do kind of age out the cache, and maybe there's some background job running and blah, blah, blah. So it's just aged out for some reason. I would have expected that. I'll have to look into that and see what's actually going on. Which version of Oracle I'm running? I'm running 19C. So, although, just note on this functionality has been in since 11G. That's 11 release 1. So this is decade-old technology. This adaptive cursor sharing. Alrighty then. Good questions. Let's move on a bit. There's some other things I wanted to talk about. So next thing I want to do is actually, I said there was consultant ID, and I want to do some searches based on that. And just to kind of demonstrate, each consultant has about 164 rows on average. So what I'm going to do is combine these 2 criteria. So we've got an index on consultant, an index on start date, and we're going to search for, those two values we did originally. So we've got 1st, 2nd of January. Index on both of these columns. Who wants any takers or votes on what's going to happen here? So there's 3 possibilities: index on consultant, index on start date, or full table scan. Any guesses or takers on this, on what might happen here? So just, if you want to say in chat, just say consultant, date, or full. Index and consultant, depends on the clustering factors. Full, so we've got a few different things. All right then, so let's see what actually happens. So we're going to run the query, and keeps disappearing off like that. So we can see, or hopefully you can see, we have used that app consultant. We have used the index on the consultant, then gone to the table and filtered out based on the dates. So why has it used that consultant? So we're getting 164 rows for that consultant from the index and then filtering it in the table. But we saw that first query, we're only getting 10 or 20 rows from the table using those dates in January. So why we use the consultant? Well, as Yuda says, comes down to the clustering factor. Consultant index is very nicely clustered. That means the data is stored in the table in an order that roughly matches the consultant IDs. So if you were to look at the data in the data files, you'd see rows for consultant 1 all kind of next to each other, rows for consultant 2 kind of next to each other, and that kind of thing. So it roughly matches the order they are in the index. The dates, on the other hand, really high clustering factor. So they are scattered throughout the table. That means rows with a similar date are not guaranteed, could be anywhere in the table where they are physically stored. And this high clustering factor probably explains why just now when we were searching for different values, different dates, it kind of looked, this is quite a high value for a clustering factor, 10,000 rows in the table, so it's about 50% of it. Use the, just go with the full table scan. So, okay, so we've used that consultant index, but we've got a date range query in here. So it is still marked as bind sensitive because it's possible, based on which values we pass here, we might still pick a different plan. Okay, so what's going to happen? I'm going to run this query again, but this time I'm going to run it again for a full year. So look for all this consultants appointments for a full year. So we'll run it once. We expect to use the plan before because we need to get it wrong at least once. So we do that, and you can see we've got the consultant. If I run it again now, which plan are we going to get? Are we going to use this index again, yes or no? So let's have another vote. Who's going to vote? Who's voting yes? Who's voting no? Yes, some yeses. Any takers for no? A lot more yeses this time. A lot more people going for yes. Oh, pretty much everyone's yes this time, looks like. Okay, so let's run the query again, see what actually happens. And just check. Yeah, that's the full year. And again, whoop, yes, indeed, we do still use that index. So even though we've vastly increased our date range, we still use that index. So at this point, it's like, well, why do we do that? The database, it is bind sensitive, but it is not bind aware yet. Why? Why has this made no difference in this situation? So Mark's saying data is still clustered. No, you're right, data is still clustered. Anyone want to take any other make any comment suggestions before we kind of look at what's going on? No? Okay, well, let's move on. So let's look at what happens if we just query for that consultant. So we've not got any date filters or any other filters in here. So we run this query, and the execution plan we get is to use that index. So if getting all the rows for this consultant uses an index, well, why would adding any extra filtering stop us using that index? Because, if we add a date filter, we are not going to get any more rows back than we've got from using this index. So this will just restrict how many rows or potentially restrict how many rows we get. So actually, even though in theory, changing the bind variables here might change the plan, in practice, actually, it has no impact whatsoever, because this index, the consult index, is good enough on its own for the optimizer to use it. So it doesn't really matter what these values are. Technically, we still marked it as bind sensitive, because technically, in theory, it might depend on those. I mean, it's possible for a small enough date range, the database might choose the date index instead of the consultant, but it's not going to choose a full table scan. There's never going to be a case where it goes, oh, we've selected a really big date range here, let's use the full table scan instead. So what questions, comments do you have about this at this point? No? No one else? Nothing? Okay, nothing to say at this point? All right then. So we've got this query where we've got consultant and start date, and we were using just the consultant. Hopefully, actually, if I pull this up, is that the right one? Is this the right plan? Come on, come on, come on. So we can see that you're using the index and consultant, and then filtering, reading those rows out of the index, going to the table, then applying the check to see whether they fit in the date range as well, and then returning the rows. So what could we do here to make this query faster? What could we do? Suggestions? Create index covering appointments, consultant, start date, end date. Yeah, good suggestion, Rafu. Anyone want to suggest anything else? Index on both columns, yes? Multi-column index, consultant plus date. Good stuff. Yes, cool, you've got it. So let's see, we've got that query. Let's see what happens when we create an index on consultant and start date. So we create that index, and now we run the query again. Apply that. We can see it is now using that consultant date index. Actually, I'll just drop that index for a second, because I meant to do something. So let's drop the index, rerun the query without the consolidated index, and apply that, and we got that. So I just wanted to pin the query and show you how we can compare them relatively easy. So we create that index, run this. So we've got the full year, and so key thing to note here is if I pin this, I've now saved that execution plan. So I can do a really nice compare them against each other and see what's changed. And you can see highlighted in red what's actually changed. We can see we're using a different index and we're applying the filters differently. So one of the key differences is, aside from using a different index, if we look at these output rows, how much data are we getting from the index? When we've got the consultant, we get 164 rows, go to the table, and then return just 60 of them. So we're discarding, roughly a third of our data. Using the consolidated index on consultant and then date, we do all the filtering in the index. So therefore, all the rows we get from the table are exactly the ones we want. And I see the comment from Sven, Rafu's suggestion should result in an index-only access path, so it has the most potential. So that is a good point. Absolutely. So let's try that out and see what happens. I will just add this start date, end date. I'll call that date start end or something like that. So we create that index, and now when we run the query again, run the query again, and okay. Let us just, So you can see actually we've now removed the table completely. We've used that consultant index and haven't had to access the table at all. So that was the most efficient way we can do this. How do we know, other than me just telling you? We look at these buffer gets figures over here. How much work did we do to have to get this data? If we go left to right, starting with just our consultant index, we did 5. That's pretty good. Not much work to get those rows. Then going over combined consultant date, 3. Nice improvement. And then all the data from the index itself down to 2. So the most efficient way of actually creating the index. Gancho, what about having compress 1 in the index creation command? Very good suggestion, Gancho. Let's try that actually. So let's take this index. I will alter this index and compress 1. So for those who don't know, index compression takes the leading values of them and essentially deduplicates them. So instead of having consultant ID listed on every single index entry, we just list consultant ID once and then have a little pointer back to it. So the index should be smaller. So now, I need to rebuild the index. Rebuild index. There we go. What's going on there? Why is that? Alter index. Rebuild. This shows how often I rebuild indexes, right? Okay. So we've rebuilt the index, and we've compressed that consultant ID. Has it made any difference? Let's find out. So got that pinned. Okay, so let's pull that up, run the same values again, and okay, it's got the same plan. In this case, hasn't made that much difference, or we'd hope maybe we'd get this down to 1 get because the index would be a smaller structure. Maybe let's see what happens if we compress 2. Maybe compress 2 might help. I'm not convinced that will help because we don't have as many duplicated start dates, but let's give it a try. Okay, so oh, and actually, see, it's gotten worse. Now you might go, why has that gotten worse, right? We compressed, we deduplicated the values, but we're actually doing more work. The index is bigger. Something you need to watch for index compression. If the values don't have a unique or close to unique, that is, there isn't a lot of duplicates, the overhead of deduplicating is greater than the savings you get. And that's actually what's happened here. As I said, we didn't have many duplicate start dates for a particular consultant. So in fact, we actually made the index bigger by compressing it 2 rather than 1. So something you need to watch for compression. Okay, so great comment suggestions here, people. Any other comments on this before we move on? Any other questions? What other questions have we got? Nope. Okay. Let me just drop this new index because before we move on. All right then. So I said the question that came in was actually quite a bit more complicated than this. This was just to kind of break it down and demonstrate some of the principles. The actual query joined to a table of, I've done a bit of inference about what they've got here, but I'm guessing they had a table with dates in or something like this. So you can see here we've got date ranges. So we're saying from the 1st of January, or for the month of January, we're going to call that the period 2019/01, February's 2019/02, and so on and so forth. So what I'm going to do is join the appointments table to the periods table. And now here's the interesting thing. I'm going to be looking for dates between these from and to for a particular period type and name. Just to show you there's actually duplicate. Each period could appear multiple times just with different names. Let's just kind of slightly recreate what the original question looked like. All right then, so we're going to run this query, and what's going to happen here? Do we think we're going to use the index on start date here? Votes, yes or no? Any takers on? Nope. No? Any other takers? Yes, no? Tricky. Sven, yes, it is tricky, isn't it? It is tricky. Because kind of similar to this situation we had before, where we're looking between binary variables, but now we're searching between column values. So let's run the query and see what actually happens. I'll just get rid of some of these other values, these other auto traces, just to make it a bit easier, see what's going on. So we'll run the query, and if we bring it up, we will see full scan of the appointments table. And cardinality estimate of 2,500 rows. So it's estimating we'll get about a quarter of the rows from the table, but in fact we get just 300. Okay, we are way out here. We know nearly an order of magnitude. Excuse me, sign that maybe there's a better plan available. Maybe. But what can we do about this? So if we look at this, I've used literals, again, partly recreating the question, but also it makes this next point a bit clearer. Again, we're comparing a start date to values where we don't actually know what they are ahead of time. Without querying the periods table, we've no idea which values are going to come back for this search criteria. And if the optimizer, you could say, well, why doesn't the optimizer query the periods table to figure out these values to then decide whether or not to use the index? Well, then we're querying the table to figure out how to query the table. In most cases, that is a waste of effort. If you're going to query the table, you may as well just query it and accept the plan you've got. Otherwise, you're doubling up on work. Remember, the optimizer has to come up with a plan as fast as it super can. If you want your query to run in 1/10 of a second, you can't spend 1/10 of a second figuring out what the best plan is. At some point, you just got to cut your losses and just do it. So if we look at that, we'll see that actually it is not bind sensitive. So even though it entirely depends what these values are, well, they're not bind variable values. They are column values. So what do we do here? Any thoughts, suggestions on what we can do here to improve this query? So just to bring up, walk through what's going on again. So we have an index on the period type. So we're referencing that. So we're finding out all the rows for that, filtering it to those between this period. They're just the same in this instance. Let's, just to help demonstrate the purpose. So we get one row from the periods table, and then we join it to all the rows from all the appointments that fall in January. So those in there. So is there anything we can do, or what can we do here? Is there anything we can do? Any ideas, any comments, suggestions? I'm hoping some people are out there kind of scratching their head a bit and kind of pondering exactly what might happen and go on and figure out what we might do. It's an interesting suggestion, Sven. Partition the two tables using the same partitioning strategy. That might work. Maybe one to try another time. I think it's a bit too much work for us to try it right this second. Well, maybe if we get time at the end, we can check it out. Yeah, maybe that might help us do partition and elimination so they can match up. That's quite a radical change, though, isn't it? That's going to affect every single query against both the tables. We want to be pretty sure about that. It's worth trying, but you want to be pretty sure about it before you're running out. Yeah, not sure it would help because of the between. I agree, Sven. I'd have to check it out to see what might happen. So, Rafu, locator indexing and SDO join. I'm not sure what you're referring to by an SDO join, Rafu. If you can explain a bit more, that'd be good. Join index might help. Okay. Oh, good suggestion. I hadn't thought of that. Join index. That is true. So, we're struggling to come up with ideas here, aren't we? And the key point is, well, we've already got an index on our appointments table on that start date. So we can't really create any indexes to improve things, or at least on the appointments table. We've already got the ideal or the candidate index that might help us. So actually it's a bit tricky to think about how we might improve this query or help the optimizer in some way or another. Now, there is an index we could create. We could create an index on the periods table. So we're actually indexing all the columns we've got there. So I'll do that. Let me just check. I've pinned that auto trace for now. So we'll create that index and then run this query again. So we'll get the auto trace up. And so the thing that's changed here is we are now only accessing the index for the periods table. We're not accessing the period table itself. But we've still got that full scan of appointments, and our estimate is still miles out. We're still way out of the ballpark. So we compare those. We can see how we're accessing the periods table, but not the appointments. Clustering table, possibly. So there's lots of suggestions, lots of good suggestions. Things, well, I don't think we're not going to get time to try them today, but maybe we can follow up later. There's something much more lightweight we could do, which might not actually change the plan, but hopefully at least will fix these cardinality estimates and bring those down a bit. We can use dynamic stats or dynamic sampling, as it used to be called. So I know I was saying don't use hints before and so on, and here I am sticking a hint in my query, use dynamic sampling. You can change this with alter session settings as well. So what this is doing is saying, do a little bit of extra work before running the query to figure out what the best plan is. And if we run this, let's just get rid of that. What do we find? What do we find? Let's pin that previous one. Well, we still got basically the same plan. Full scan of appointments, index scan of periods. But the really important thing to notice here is this cardinality for the appointments table is now back down to bang on exactly what we expected it to be. So instead of an order of magnitude too many, it is exactly bang on, which means that there's a good chance that this is in fact the best plan we're going to get without doing some of the more radical things you've all been suggesting, like clustering the table, creating partitioning, creating materialized views. So this is a bit more of a lightweight way to find out. We've got some complex criteria against these tables, and the database just, there's no real good general case strategies to figure out how many rows you're going to get back here. So dynamic sampling is saying, well, actually do that work, do the work to check these tables and see what's in there, and see what's going on. So Judith, but previously for the same dates, it chose the index. No, it didn't choose the index for the same dates before, because if we look at the periods table, the period is the whole month. So previously, I was just looking for the 1st and 2nd of January, so 2 days. Now, it is in fact searching the whole month here. So a whole, very first time we ran this query, we got 10 rows back. Now we're getting 300 rows. And I think the point here is not necessarily whether or not it used the index. The point here is this cardinality, the estimate, the guess about how many rows we're going to get is now in the right ballpark, meaning the database is much, much more likely to get the best plan. No, the first query I ran was 10 rows. If we bring that back up, so if I just run that one again very quickly, if we see this, we will see, let's just change that. 2, and it's gone back to the index again, as we would expect, just 10 rows, just 10 rows. So anyway, okay, we're getting close to the hour. There's one other thing I wanted to cover. The real query that they sent was even more complicated than this. Okay, so we're building up gradually. We've been lots of good comments and suggestions about what we can do to change this, but the real query was even more complicated. If I can find out where it is, there we go. So what we actually had is we had throw in some locations as well. Okay, right. And hopefully this is actually going to do what it did in my preparations earlier. Exact, perfect. There we go. So, and they had a plan that looked a bit like this. So the interesting thing here is we've got our locations table. We then join it to the appointments table, and then we join our periods to the appointments. So location, join to appointments, join to periods. What does the optimizer do? Well, first thing it does is it accesses the locations table and then joins it to the periods. We don't have a join between those two tables, right? What's going on here? Why has it done that? Well, it's expecting exactly one row from both of those tables. And if you're expecting one row, and you're pretty sure you're going to get one row, then actually just joining those tiny data sets together first is a good, valid strategy. You've actually got a Cartesian product between them. And I don't have it in this instance, but the original question, they did have a merge join Cartesian, even though there was a join there. Why? Well, if you query getting one row from a table, then just joining it to another table, nested loops and merge join, is absolutely perfectly valid. But the problem here is now, because of all these date range queries, is this the best way to access this other table? It's like, well, I don't know. It kind of depends, really, doesn't it? It depends on how many rows we're getting from these first two joins. What if these stats are wrong? What if these guesses wrong? What if we didn't get one row? What if we got lots more than one row? We probably want to use a different join here, or access this consultants table differently. So that's something we introduced in 12C, adaptive plans. So I disabled them for this just to make sure everything did exactly what I predicted it would do. If we run the query again with a different plan, it's starting to look a lot more complicated. And if we compare them with AutoTrace2, see a lot of red in here in terms of what's going on. Lots of other stuff. Key thing to note here is we've got this statistics collector step in there. And unfortunately, it's a bit tricky to see in SQL Developer, but if we get the good old DBMS X plan with the adaptive option, it tells us this is an adaptive plan. That means it can choose the type of join at runtime based on how many rows it actually returns. Sorry, I wanted to go this way. So we've got a whole bunch of filters. We notice those lines with the minus started. They never happened. They were plans that were considered but never took place. Why? Because this statistics collector is looking at how many rows come out of this nested loops. As long as that stays small, below some threshold, it will just continue up to these other nested loops. But if that's large, well, we want to change to our join, to our hash join, do that instead. So it now enables the plan to actually adapt and follow. So I had to whip through that rather quickly, as we had lots of great chat and questions earlier. What quick questions or comments do you have on that? No? Is it too much thinking now? You're like, oh, come on, Chris. It's been an hour. You've been asking me too many questions. Stop. Just give me a break. All right, then. So I was going to run through this, but we're kind of out of time, unfortunately. So one final quick question before we wrap up. What did you think of this kind of walking through the plan, looking at how things work? Yes, no, good, bad, indifferent, thumbs up, thumbs down, yes for no? Yeah, no worries. CS Amanda, thanks for your presentation. We're pretty much done. So good thumbs up from Sven. Any other thoughts on this? Would you like to see more of this kind of, we walk through, we do live tuning of a query. We walk through what's going on, break it down to parts and see what's happening. This is good. Yes, a few yeses. Okay, good. All right then, cool. I'll bear this in mind. Okay, walkthrough is good. You liked it. Excellent. All right then. So just a general suggestion or to you, if if you've got a query you're struggling with and you'd like us to do this kind of live tuning with it, then get in touch with me and we will see what we can do to produce realistic demo and examples so we can actually walk through the process and see how it all works. So if you are interested, at me on Twitter, Chris R. Saxon, or my email's chris.saxon@oracle.com. Get in touch and we'll see what we can do. So, we can do a live tuning on maybe something you're really struggling with. So I think that would be really cool. All right then. So thank you all for sticking around. We are at the hour. I'm just going to wrap up very, very quickly. So as we said, one query can have many good plans. Depends on the bounding variables that you've passed. In 11G, we had adaptive cursor sharing, which allows it to the database or the optimizer to spot this based on the bounding variable values. But it's not perfect. We saw that date comparing to columns still didn't help. Dynamic statistics, cranking it up to 11 can help things even further. And finally, adaptive plans in 12C can help the database, if it's not sure which is the best join method, to choose between nested loops and hash join and choose the appropriate one. So all that's left to say is really thank you all for joining us. It sounds like you really enjoyed this, and I've found this useful too. So looking forward to seeing you next time, and goodbye. See you soon.